Hey y'all. Uh, I'm so sorry I can't be there today. I feel really sad. This is my favorite thing. I call it something completely different than anybody else because, of course, I do. Um, this is called integration by parts, and I often forget that that's what the name of it is. Um, Integration by parts is useful when you have a product because you cannot multiply two integrals. So, for example, I'm going to write something way up at the top. The integral of x dx times the integral of, say, sine x dx is actually an area times an area. And a bunch of you tried to do that on Monday. That is very different than the integral of x times sine x dx. These are up here, these are two integrals being multiplied, and down here, that is, or two areas being multiplied, and down here, that's one area. So it's a really important distinction, and you need to understand, which we went over a long time ago, like right when you were first learning integrals. So you need to look over your notes and remember the properties of integrals. Like you can add them, but you can't multiply them. And some of you have forgotten that. So here, when we take our derivative, in order to figure out how this all works, we're going to take our derivative using the product rule. When we use the product rule, we get u dv over dx plus v du over dx. And I'm sorry my writing is going to be a little sloppy because I'm in a little bit of a hurry, and I apologize. If you were to take that same thing and integrate both sides, uh-oh, just like that, you would actually get, sorry, I don't usually talk and write at the same time. I'm totally pulling a Roblo. You would actually get, crap. That's not where I want to go. Sorry. Trying really hard not to panic. Okay, you would get UV equals, that's not what I want. Why? What is happening? Oh, crap. Y'all. Shit. I can't erase. I mean, I can, but I can't. There's a problem here. There's a problem with erasing here. Oh my gosh. Okay, I'm trying not to panic. I can't re-record once I've started talking. So this right here is u dv dx plus v du dx. And I can't integrate right away, right out of the chute like that. But you can think of it in terms of uv prime plus vu prime. And some of you are just now realizing, even though I've talked about it, it's okay if you don't remember, that dv dx is the same as v prime, and du dx is the same as u prime. So if you integrate both sides, so we're actually going to integrate, let's see how I want to write this. The integral of u v prime, oh crap, how did I even do that? U v prime dx, that was funny, plus the integral of v u prime dx, and you will get the integral of u dv, oh, that didn't turn out pretty, plus v du. I feel like I skipped some steps or something. So, give me a second to pause so I can think through this, so I can stop talking so fast and making so many mistakes. I can't even push pause. Okay, so now I'm processing over on the right-hand side of the page, and the stuff at the top is still relevant. That stuff right there is important to remember, and some of you have forgotten about it. If you were to take the derivative using the product rule, you would have the derivative of u times v equal to uv prime plus vu prime, which, when integrated, you can see that this v prime, which is dv over dx, creates a situation where the dx's cancel. Same with the u prime, the dx's cancel. So we have this crazy looking formula over here that is actually super useful. Don't ask me who discovered it was useful, because I don't know. Somebody like Ramanujan. In any case, when you go to rearrange it, you discover that if you have a function, the integral of a function and the derivative of another function paired, they actually equal the original of both functions, their product, minus the integral of the original of the function that you originally had the derivative of times the derivative of the function that you originally had the original function of. Okay, so how does that work out? And I call this UdV/VdU, and when I was your age, I simply memorized this formula, UdV/VdU, even though all I'm saying are just, I'm not saying much TBH, but anyway, I'm just saying this part and this part because this middle part is super easy to remember. Okay, and that's what you really wish it integrated to, but gosh darn, life isn't that simple. Here we have the formula, which we just wrote, so I don't know why we're writing it again, but anyway, we'll just fill out this silly worksheet. UV minus VDU, there. Here on this next bit, we have x sine x dx. And if you look at that carefully, that x, if we were to take the derivative of it, I'm going to write way out at the right, the derivative of x is 1. So that means that x is easier to differentiate. And that means that x is our u. So if x is easier to differentiate, it's easier to get rid of it if we make it our u. So that means that sine x dx is our dv. Okay, so now we see that dv is sine x dx, therefore v is negative cosine x. So now all you need to remember is this silly formula, UdV, VdU. Right? Even though I'm saying it wrong, it's the way I say it. And it's actually called integration by parts. But anyway, maybe my stupid things will help you remember. Give me a second. I don't know why I keep telling you, give me a second. You don't know that I'm pausing. So we simply pop it into the formula, And by the way, those 3 dots mean therefore in math. I don't think I've ever used that notation before, or at least I haven't in a long time. So now we have something that we can actually integrate, and we see that we end up with negative x cosine x plus the integral of cosine x would be, dun dun dun, Aiden, what would it be? Tell us all, Aiden. You can do this, Aiden. John believes in you. Yes, Eli, it is the sine of x, oops, crap, plus c. I make those streaks when I'm trying to move the screen. Okay, so look, it looked impossible at first, but using this little formula, it becomes super easy. And that formula is simply derived from the product rule. It's the backwards product rule. Okay, now we're going to move along. Okay, if you look at this one, that x squared eventually goes away. That e to the x will never go away. So what we know just looking at that at first blush, haha, I'm pretending to be an English teacher. Your u is x squared and your dv is e to the x. What does this mean? If u is x squared, then du is 2x dx. What does it mean if dv is e to the x? Oh, y'all, I wasn't very alert, was I? There we go. If dv is e to the x dx, then v is e to the x. So I'm going to simplify that very quickly, and then we're going to see an issue that is very easily resolved. Just look at those directions. You already know where we're headed. Okay, so just like the directions say, you're going to need to repeat the process. Your new u, which you can give it a different name if you want to. I'm just going to stick with u. U is x, which means that du is dx, and dv, again, is the gross thing that won't go away, e to the x dx, which means that v is e to the x. And I'll go ahead and simplify that real quick. And from here, it simplifies very, very easily. It is a nasty looking answer, but it also was a lot less complicated than it appeared. There's a lot of substitution going on, but I believe all of you can handle it. From here, you may want to factor, but I would definitely hold off on that until you see your multiple choice answers, because more than likely this is going to be in the multiple choice. And you want to make sure that you factor the same way that the test writers factor. So keep it unfactored for the time being. Right away when you look at this, you should see that your u is x squared, because that is the piece that can disappear. You can also see that your dv is e to the x dx. You can also do this a different way using a table. So using that table, we can talk about, we can keep track of signs and things like that. I will upload a video explaining tabular integration, because I see a really good one. And, let's see. I'm trying to decide. Okay, I gotta think on this. Okay, as you can see, the sign of the first term here is positive, and this second bit is negative. I did not change that into an equals. That is a negative right there. When you go to do your tabular integration, you can keep that in mind as you work through it. Okay, so I am not a fan of the tabular integration, but it seems to help a lot of people. So this helps you create your next step in the integrals. So if you look at that, you're going to start with a positive uv, and that uv is paired as follows. I'm sorry I'm talking so weird. These two go together. Then in the next piece, these two will go together. And I forgot the last one. And then these two will go together. And then you will have done the entire process that I did before using this table. And I happen to understand it better the other way. So I know that my explanation is lacking, which is why I am going to include the other video. Even Khan Academy does a really good job with this. I don't know what to call this. We'll call this giant bold V there. That's still e to the x. So we end up with here x squared e to the x minus 2x e to the x plus 2 e to the x. To me, this just feels too much like a trick, and I don't manage tricks very well. So if you like this, again, I'll post a video that will probably be more helpful than what I have done. And I'm going to go right back to what I was doing before and do this next example using my method. What would your u be here? Your u is the thing that's the easiest to get rid of. So u is x squared. Oh yeah, and there's an, I'm so sorry to interrupt myself. If you look at this, if you look at the previous problem right up here, it bothers me that there is no dx on anything. It's all like, I don't know, it feels too much like a trick to me. It just really bothers me without the dx, and we're not really keeping track of stuff, and we're making up names. But you can do it on scratch paper. It's completely, I just wouldn't leave it in your answer or explanation if it's a free response. So here your u is x squared. Or is it? Which one is easier to get rid of? Is your u x squared, or is your u the natural log of x? Well, let's think about this. Du would be 2x dx. Du over here would be x to the negative 1 dx. And we want something that goes away. Okay, I stopped the video because I suddenly realized that your x's are going to cancel. Da, da, da. So we have an x to the negative 1, which will cancel with whatever we have over here. So I'm going to try to mess around with it that way. And I'm going to get uv, so 1/3 x cubed natural log of x, all minus v, which is 1/3 x cubed times du, which is x to the negative 1 dx. Well, what do you know? That, I don't know where to put this next bit, turns into x cubed over 3 natural log of x minus 1/3 the integral of x squared dx. And all of a sudden, you have gotten rid of that natural log. So you had less work than you ever imagined on this problem. And you actually end up with x cubed over 3 natural log of x minus, this piece integrates beautifully into 1/9 x cubed plus c. Holy cow, wasn't that so much easier than you expected? I forgot the plus c up there. Y'all, you should told me. Why did you tell me? Plus c. Did I forget the plus c on any of the other slides? Oop. Can you see me switching slides? Oh, I did. I hope you can see me switching slides. Oops, plus c. Oh my gosh. There we go. I can't believe I did that. Ugh. 0 points for me. Okay, next one. We are going to integrate this next one without the limits first. Oh my gosh, I've been talking forever. And the one that doesn't go away is the sine of x. So we're going to make that our dv, which makes our v negative cosine x. Oh, crap. Sine x dx. Then our u is x, which makes our du dx. So if this was an indefinite integral, this would be my answer. Notice that I crossed off the equal sign right back there, and I just worked it out using what I knew. And then I'm going to do what I did whenever we were talking about u sub and the way I don't usually change the limits of integration. This is one of the reasons that I don't change the limits of integration in u sub. It just makes this a lot easier to work with. So when I go in and put this in using my bounds, again, we get rid of that c because it would cancel. And there we go. We have 1 for an answer. What a long route to get to 1, right? So we just did that one. I accidentally smushed that on a page. We're going to look at the next one. Oh my goodness. Who thought those silly trig formulas would ever come in handy? Maybe they will, maybe they won't. Look at that. They both go on forever. Ah, what are we going to do? Obviously, there is some new thing that we need to learn, right? I happen to, this is my favorite part. I love this stuff. I know I'm a math nerd, but it's okay. Some of you are too. Okay, so I tried to start out normal, but then I turned into Marty, and then it was all over. But really, I started the problem out normally, and then I tried to figure out what my new U and my new V were, and some magic is going to happen. It feels like magic to me, because what looks so complicated becomes suddenly so simple. But the real complicated part is recognizing when to use what. You guys have already figured that out. And holy cannoli. Our question is in the answer. And now it becomes very much like an algebra problem. So I'm going to rewrite this, and then I'm going to solve it like an algebra problem. So I'm trying to take this piece a little bit slowly. All I did in this step was cut out the middle piece so you could see more clearly what's going on. So again, I just cut out the middle piece there. And then I'm going to try to get these pieces on the same side because I think they're the key. Okay, I'm trying to break it down really piece by piece for you. And all I've done in this step is distribute this 2 to that piece and that piece. And I know that 2 times 2 is 4, and then I can put that constant out front. So that's all I did in this step. Now I'm going to take this little stinker right here and add it to both sides. Hey, look at that. We have actually integrated one side just by putting all of our integrals on one side, and now we're going to divide both sides by 5, and we have what is in fact our answer. And there you go. That is one of my favorite things in calculus. I don't know why. Anyway, I hope you had fun listening to this, and I'm about to make the second video, but first I got to take my little doggy for a walk. Oh wait, it's not a second video. It's just one really long video. Oopsies, but I need to take a break because Roxy needs to potty. Okay, folks, we're almost done. We're halfway through, but we're 30 minutes in. But anyway, you need to know your integrals, your trigonometric integrals, and you have some helpful guidelines at the bottom here. I highly recommend you don't just look them over. I highly recommend you imprint them inside your brain. You know, tattoo them inside your forehead. If the power of the cosine is an odd positive, if it is odd and positive, save one of the cosine factors and convert the remaining factors to sine. If the power of the sine is odd and positive, save one of the sine factors and convert the remaining factors to cosine. You're going to see how that works in a few seconds here. So here we have an odd and positive cosine power. So we're going to save one of the cosine powers and convert the remaining factors to sine. Then we're going to expand and integrate. What does that mean? You're going to see. So far, all I've done is separate out that one cosine that I'm going to save. And here you see that I have replaced cosine squared with 1 minus sine squared. Now we're going to distribute that, and we are going to be able to easily integrate that. I just combined 2 steps. I did the distribution, and then I separated it into 2 integrals. And that first piece is super easy to integrate. The second one, you might need some UDU. I will write it down for those of you who do. So what happened here was I decided that u was sine of 5x, therefore du was 5 cosine 5x. I had to solve for what was actually in the integral, and the actual value in the integral is cosine 5x dx, or cosine 5x dx, which makes our I don't know what to call that, which makes which is equal to 1/5 du. I'm sorry, it's almost 11. I'm having trouble staying awake. Okay, so there you go. There's how you integrate those little boogers. And we're going to move on to the next one. And which one is odd and positive? It's the cosine. So it's going to be the cosine that we're going to reserve, and we'll replace the cosine squared. Because in that cosine cubed is the cosine squared. I did a little rearranging first so that I had everything grouped up. This expression over here is going to become the derivative of my original expression. So I rewrote it using the Pythagorean theorem. I distributed that and broke it up into two pieces at the minus. And now I'm simply going to integrate it. And most of you should be able to do this without u substitution. I am not going to write this down using u substitution. P.S. Tomorrow we have fit. There you go. That was pretty painless, I think. So tomorrow when you come in for fit, you need to bring your assignments and make sure you're prepared to ask questions, because I am feeling pretty nervous about the fact that I'm missing today, especially because it's super easy for me, and it usually is hard for most of you, especially knowing when to use what. Again, the problem is not the little individual skills, it's knowing when to use what. Okie dokie, here we continue. Okay, so here I followed the directions. Both powers are even and non-negative, so I replace them with their respective formulas, which are two of the hardest formulas to remember on the formula chart. And then I multiplied it out, and I can take out the coefficient and break it up into two pieces, taking out the coefficient from the first one, from the second part of the integral, and it becomes super easy to integrate. Now I did have to use that formula one more time in this step, but from there on out it was smooth sailing, and I have an answer. My answer is kind of clunky. You can simplify it. You should get, assuming I know how to numbers this late at night, 1/8 x minus 1 over 96 sine of 12x plus c. If you see any errors at all, we need to go over those tomorrow during fit. I'm so sorry, I should be clear. If you see any errors in my work, we should go over those tomorrow during fit. This next one looks a little crazy, but it's actually easier than it looks, because you're going to have to use the same formula twice. I'm sorry. Let me just do it, because I can't make sense. My words, no. So here, I just FOILed it out. I simplified my fractions, and I can separate this into three separate integrals. That end integral, this end piece over here, oh my goodness, that's so messy. That end piece over there, that will break down yet again, and I'm going to do that very quickly. Then we get down here to the bottom, and we see that everything integrates super simply at the end. Again, I know I've said this about 50 times during this video. The hard part is not the individual pieces, it's figuring out when to use which. So there are a few rules in here about when to use which, and I am so sorry that this video was so long. I wish I could re-record it, but I can't. I gotta go to bed. Y'all have a great day. I miss you. I miss you so much. Except Aiden. I don't miss Aiden. I miss everybody else. I have jokes. They're bad jokes. Actually, I do miss you, Aiden. Y'all take care. Bye.